This video is one of two in which we'll learn about ratios and percents in Math 6. The concepts and methods introduced in this first ratio video will be echoed in the second percent video. Ratios and percents express relationships between quantities. They can be used when solving problems such as scaling a recipe or determining a discounted price. Let's begin by exploring ratios. Take a moment to look at this puzzle and its pieces. What do you notice? Think about how the pieces are the same and how they're different. What comparisons between the number of pieces can you make? There are many possibilities. You might have compared the number of triangles to the number of four-sided shapes. These are called quadrilaterals. There are 10 triangles to 4 quadrilaterals. This comparison is called a part-to-part ratio. You might have compared the number of large triangles to the number of small triangles. There are 4 large triangles to 4 small triangles. Or you might have compared the number of purple pieces to the total number of pieces. There are 2 purple pieces to a total of 14. This comparison is called a part-to-whole ratio. You might have expressed this relationship as 1 to 7. These ratios are equivalent. We'll further explore equivalent ratios in the following investigation. Suppose you are making a necklace using a black, red, 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 black pattern. This relationship can be expressed using 2 part-to-part ratios, 2 black beads to 3 red beads, or 3 red beads to 2 black beads. Note that when expressing ratios, order matters. 2 to 3 describes black to red, whereas 3 to 2 describes red to black. What if you repeated this pattern? Using this same ratio, how many beads of each color might you need? Repeating this pattern would give you 4 black beads to 6 red beads. 4 to 6 is equivalent to 2 to 3. Likewise, 6 to 4 is equivalent to 3 to 2. Continuing gives more equivalent ratios. There are 2 sets of equivalent part-to-part ratios. The necklace can also be described using equivalent part-to-whole ratios. Part-to-whole ratios can be written as fractions. For example, 2/5 of the beads are black and 3/5 of the beads are red. Let's explore determining an unknown quantity using ratios. A smoothie recipe calls for 4 cups of strawberries to 2 cups of raspberries. Suppose you're making several fruit smoothies and have 10 cups of raspberries on hand. How many cups of strawberries will you need? We can organize this information in a table, gradually increasing the cups of berries using the ratio 4 to 2 until we have the number of cups of strawberries corresponding to 10 cups of raspberries. 8 cups of strawberries are needed for 4 cups of raspberries. 12 cups of strawberries are needed for 6 cups of raspberries. 16 cups of strawberries are needed for 8 cups of raspberries. And finally, 20 cups of strawberries are needed for 10 cups of raspberries. There are more efficient strategies for determining this value. For example, notice that 10 cups of raspberries is 5 times 2 cups of raspberries. Multiplying 4 by this same factor gives 20. Also, notice that in each equivalent ratio, the number of cups of strawberries is double the number of cups of raspberries. We can solve for this value by writing a proportion. A proportion is an equation that says that two ratios are equivalent. Applying the same scale factor as above, again gives 20. Let's apply our understanding of ratios. In Surrey, we work and learn on the unceded shared territories of the Coast Salish, Katzie, Semiahmoo, and Kwantlen First Nations. Your child may be learning that in many First Nations, certain animals are significant or sacred to the teachings, histories, and beliefs of that nation. Each will have their own protocols around ways in which these animals are portrayed. We are all connected to this land by Phyllis Atkins. Kwantlen First Nation is installed on a small bridge on King George Highway spanning Bear Creek. The design features animals four-legged, feathered, and finned, mirrored on both sides of the bridge. Consider the following four-legged, feathered, and finned animals and the ratio 1:2. What is being compared in the ratio 1:2? Think of as many possibilities as you can. You might have compared the number of four-legged animals to the number of finned animals. There's at least one more possibility. You might have compared the number of finned animals to the number of feathered animals. There are 2 finned animals to 4 feathered animals. And 2 to 4 is equivalent to 1:2. You might even have seen 1:2 as a part-to-whole ratio. The orca is one of 2 finned animals. We invite you to talk about other ratios that you and your child see. A school orders 3 pepperoni pizzas for every 5 cheese pizzas. The school orders 30 cheese pizzas. How many pepperoni pizzas will they order? We can record equivalent ratios in a table until we have the number of pepperoni pizzas that corresponds with 30 cheese pizzas. Tripling 5 cheese pizzas gives 15. And doubling 15 gives 30. Applying this multiplier to the number of pepperoni pizzas gives 18. The school will order 18 pepperoni pizzas. There is a more efficient strategy. Multiply both 3 and 5 by 6. Initially, your child may not always choose the most efficient strategy. What's more important is that they are developing number sense and proportional reasoning. You can help your child connect multiplying by 3 then 2 to multiplying by 6. As we did earlier in the smoothie exploration, we can record the strategy using a proportion. Note that both the numerator and denominator of the fraction on the left have been scaled up by a factor of 6 on the right. Next, we'll discuss curricular connections. This video addresses several learning standards in the Mathematics 6 curriculum. Let's take a closer look. In content, we were introduced to ratios. As your child learns about ratios in their classroom, several curricular competencies may emerge. For example, when we explored ratios, we developed mathematical understanding through problem solving. Later, we applied this understanding to solve a new set of problems. Inspired by Indigenous art in the local community, we engaged in problem-solving experiences connected to place and cultural practices of First Peoples communities. The beading exploration presents a similar opportunity in your child's classroom. Please watch the second ratios and percents video to learn more about extending the ideas discussed here to percents.